Today, we will talk about goodness of fit explained. Goodness of fit refers to a statistical test that determines how well sample data fits a distribution from a population with a normal distribution. It hypothesizes whether a sample is skewed or represents the data you would expect to find in the actual population. Goodness of fit tests make inferences about observed values to determine whether a sample group is truly representative of the entire population. There are multiple types of goodness of fit tests, including the chi-square, Kolmogorov-Smirnov, and Shapiro-Wilk tests. To interpret a goodness of fit test, statisticians establish an alpha level, such as the p-value for the chi-square test. The p-value refers to the probability of getting results close to extremes of the observed results, assuming that the null hypothesis is correct. The chi-square test is used to determine if a relationship exists between categorical data. It is used exclusively for data separated into classes and requires a sufficient sample size to produce accurate results. The Kolmogorov-Smirnov test determines whether a sample comes from a specific distribution within a population and is recommended for large samples. It uses a null and alternative hypothesis and an alpha level of significance. The Anderson-Darling test is a variation on the KS test but gives more weight to the tails of the distribution. It is more sensitive to variations observed in the tails and can provide more power in financial analyses. The Shapiro-Wilk test determines if a sample follows a normal distribution and is recommended for small sample sizes up to 2000. It uses a probability plot called the QQ plot to estimate the variance and determine if the sample belongs to a normal distribution. Goodness of fit tests provide a way to assess how well a statistical model fits a set of observed data and help identify outliers or market abnormalities. They also provide information about variability and the estimated parameters of the model, which can be useful for making predictions and understanding behavior. A goodness of fit test is used to evaluate how well observed data fits a particular probability distribution, while an independence test is used to assess the relationship between two variables. They are designed to answer different questions. A hypothetical example can be used to show how the goodness of fit test works. For instance, a small community gym could use a goodness of fit test to compare its assumed attendance with observed attendance to determine how to best manage the gym and improve profitability. Goodness of fit is a statistical hypothesis test used to see how closely observed data mirrors expected data. It can help determine if a sample follows a normal distribution, if categorical variables are related, or if random samples are from the same distribution. Goodness of fit tests help determine if observed data aligns with what is expected and can be used to make decisions based on the outcome of the hypothesis test conducted. For example, a retailer can use the results to reform their campaigns based on the product offering that appeals to young people. The chi-square test determines whether relationships exist between categorical variables and whether the sample represents the whole. It estimates how closely the observed data mirrors the expected data, or how well they fit. The goodness of fit test consists of different testing methods, each with its own unique formula. The goal of the test will help determine which method to use, based on the desired outcome. Goodness of fit tests determine how well sample data fit what is expected of a population, and there are different hypothesis tests available depending on what outcome you're seeking. Choosing the right test depends on the sample size and the specific information you want to know about the sample. Here are 3 key takeaways. 1. Goodness of fit tests can show you whether your sample data fit an expected set of data from a population with normal distribution. 2. Chi-square test determines if a relationship exists between categorical data. 3. There are multiple types of goodness of fit tests, each with its unique application and significance. Hope this would help. Thanks for watching.